In this video, I want to begin talking about two-sample testing. Where instead of comparing a sample to old data, we begin to compare samples to one another. First, just a quick review of what a p-value means. Which of the following are true statements? The p-value of a test is the probability of obtaining a result as extreme as the one obtained assuming the null is true. Well, let's talk about the definition of a p-value. Really, at the heart of a p-value, it's the probability of our alternative happening, our sample's occurrence, under the assumption that the null is true. Okay, it's like conditional probability, and again, it's what's the probability of the sample's occurrence if the null is true. So really, Roman numeral 1, that is absolutely correct. Okay, if the p-value for a test is 0.015, then the probability the null is true is 0.015. No, that is not the definition of a p-value. It's the probability of the alternative, that sample's occurrence if the null is true. And when the null is rejected, it is because it's not true. Well, that's false because, of course, we have type 1 error, where we may reject the null based on its low probability, but that doesn't mean it's not true. That just means our sample gave evidence against it. So it is Roman numeral 1 only. So, a study is conducted to see if men and women feel differently about censorship. A simple random sample of 350 men and 310 women is taken with 210 men and 120 women saying that censorship is unconstitutional. So, I want you to notice that we have two distinct samples now. We have two n's, or sample sizes. In that menu of tests on your calculator, oftentimes you have to decipher which thing you're going to use. One of the first things I would decide in reading a hypothesis test or confidence interval problem is how many samples were taken. In this case, it is 2. Now, before we get going too much, I want to talk about this, how these things would be distributed, what they would look like. So here you can see I quickly calculated my two p-hats. My p-hat for men, my p-hat for women. So I imagine that my distribution for the difference in proportions, because remember, this is just a sample, and we're going to try and build a confidence interval in the end of this. The shape, center, and spread of the difference between my two proportions, well, we're going to be centered around the difference that I've calculated here between my p-hats. 0.6 minus 0.39 is 0.21. That's going to be the center of my distribution. The shape, well, as long as all conditions are met, we're going to check our conditions in that plan phase of our confidence interval, we're going to think that it's normally distributed. And the spread, well, we have a new standard error that we want to talk about. Let me show you the formula sheet. Okay, so back on the formula sheet, that inference page, we had remember our confidence interval was always the statistic plus or minus critical value times standard deviation. So we've dealt with these two statistics and these deviations. Now we're doing the difference of proportions. This is our standard error, okay? So we do have a special case, you'll see, when proportions are equal, but of course ours are not. So our spread is going to be 0.6 times 1 minus 0.6 over 350 plus 0.39 times 1 minus 0.39 over 310. Okay. And before you take the square root, remember you have variance, so that's why we're able to add these kind of separate, standard, or these separate variances together and then square root. So this, as long as all conditions are met, this is our distribution for our difference in proportions. So now I want to create a 99% confidence interval for the difference between the proportion of all men and all women who believe that censorship is unconstitutional. The process here remains the same. It's still our four-step state, plan, do, conclude. Our state would look something like this. And the key here, you'll see we want to build a 99% confidence interval for the difference. So we calculated a difference of 0.21, but that's based on a sample. We want to create an interval for the population difference. Okay, so that's kind of the key here, is that word difference and the proportion of men and women who view censorship as unconstitutional. Now, the next step is of course, a plan. Now, this, of course, we have a little more work to do because we have two simple random samples. That's good. Simple random samples. I'll put a little S there. 350 men. That's less than or equal to 1/10 all men. And we also have to do the same thing, of course, with women. 310 is less than or equal to 1/10 all women. And then we have to do our 350 times 0.6, which was 210. That's bigger than 10. And 350 multiplied by 1 minus 0.6, which is 140. That's bigger than 10. Over here, we'll do 310 times, now I had rounded that 0.39, but I'm going to write down that it was 120. And then we do 310 times 1 minus 0.39, which, again, due to rounding, it's not going to come out to be exactly 190, but if I hadn't rounded, it would. Okay, there we have it. So nothing too crazy. We have one added condition here that we need to talk about. And let me give you kind of a counterexample to this condition. And that is, if I flipped a coin 100 times, a fair coin, and I got 53 heads, that means I got 47 tails. So if I say, well, I'm going to do build a confidence interval for their difference, the minute that 0.53 heads, that proportion of heads is set, I know the proportion of tails. They are not independent of one another. If one changes, the other changes. I should not be building a confidence interval for their difference. I should be building a confidence interval for just the proportion of heads. Our added condition is that our samples are simple random samples and they are independent of one another. Okay? Now, let's keep going with this. Let me kind of clear some things out. All right, so now I have a little more room to work with. The do part of this. Now, I'm assuming that you will almost always use your calculator, but let me show you the formula for a confidence interval for proportions. Okay, the formula looks like this, so a confidence interval. And this really comes from that formula sheet, where we have a difference in our two p hats, plus or minus our test statistics, which is z because we have these conditions that we met, and then our standard error for the statistic right there. But again, I'm not thinking you'll probably use that. You'll use the calculator. Let's look at where that is in the calculator. So you are going to go into your test menu where we've spent so much time in the last couple chapters. You're going to find the two proportion z interval, and you're going to put in your information about the first p hat, the second p hat, and your confidence level, and you're going to calculate. And when you calculate, it gives you the interval. I'm going to round here to 3 decimals, so we've got 0.115 and 0.311 is my do step. And I should probably just say I did a 2 proportion z interval. Okay. And conclude. We are 99% confident that the interval from 0.115 to 0.311 captures the true difference in the proportion of all men and women who view censorship as unconstitutional. And again, the key word there is difference. Okay, it's not a proportion of men, it's not a proportion of women, it's that they are different than one another. Okay, if that confidence interval contains 0, ours is all positive. If it contains 0, that might insinuate that they don't feel differently. if there's an overlap there and that their difference may be zero. Okay, but here we're pretty confident, of course, that there is a difference, and it's a positive that more men than women feel it's unconstitutional.